Before we go to our next examples, let me talk about three different types of solutions. We have the null set, which means no solution. We have the one solution, which means one solution, and that's what we usually see. And then we have identity solutions, which means infinitely many solutions. In symbols, the null set A is equal to B. Whenever you end up with opposite number or different numbers, then it's a null set. Obviously, A cannot equal B, and that would give us a null set. When we get one solution, we end up with the variables equal to something. So for example, X is equal to A. And then infinitely solutions, or identity, is when we end up with A is equal to A. So let me go through these three examples so you can see this. So in the first example that I have here, I need to combine the like terms, the 3x, and so I'm going to subtract the 3x. And what ends up happening is the 3x's are eliminated. 3x minus 3x is 0. 3x minus 3x is 0. So all I'm left over with is 4 is equal to 0. And we know that 4 does not equal 0. So this would be called a null set. Or you can say no solution. In our second example, again, I'm trying to isolate for the variable. So I divide by 2. 2 divided by 2 is 1. So I'm left with 1x is equal to 10. I end up with one solution. So that's why this would be called one solution. In my next one, okay, I'm combining the like terms. So let's start with the 2. 2 minus 2. Okay. Now I'm left with 4x equal to 4x. Well, I need to combine them. Well, I know 4x equals 4x. Well, no matter what number I plug in here, it's going to still be the same answer. But let's go ahead and keep going. Minus 4x. I end up with 0 equals 0, which gives me an identity, which is infinite number of solutions. Example number 2. Solve 6 times x minus 3 plus 10 is equal to 2 times 3 times x minus 4. So once again, our goal is to isolate for the variable, but in order to do that, we're going to have to do the distributive property, and it looks like twice. Let's start over here on the left hand side. We are going to take 6 times x, which is 6x, minus 6 times 3, which is 18, or negative 18, plus 10 equals, on the right hand side, take the 2, distribute it to the 3x, 2 times 3x, 6x, 2 times negative 4, negative 8. So now let's combine like terms. Let's start on the left hand side first. So let's combine the negative 18 and the 10. That gives us negative 8. So we'll have 6x minus 8 equals 6, 8 minus 8. Now I don't know if you see it, but this is the exact same equation or expression on both sides. So when we end up with the same equation on both sides, that is going to say our answer. I mean, we can work it out and you'll see it. Let's add 8 to both sides. That eliminates the x, I mean the 8's. So I'm bringing down the 6x equals 6x. If we were following our protocol to isolate for the variable, we would divide by 6 and we get x equals x. And when you get that, that's called an identity. And an identity means all numbers is our answer. Example 3. Solve 8 times 4 minus 2x equal to 4 times 3 minus 5x plus 4x. So again, in order to get rid of the parentheses, we're going to use a distributive property. And the distributive property tells me that whatever number is outside, in this case I have an 8 and a 4, I'm going to multiply into the parentheses in order to get rid of the parentheses. So let's start with the 8. Multiply that times the 4. 8 times 4 is 32. Then I take 8 times negative 2x, which is negative 16x. That's going to equal, now let's do the same on the right hand side, 4 times 3, which is 12. 4 times negative 5x, negative 20x. And let's bring down that plus 4x. Okay. Before we start moving anything around, let's combine like terms. Okay. Let's combine like terms that are on the same side. And in this case, I see the negative 20 and the plus 4, so I'm going to combine those two together. They both have an x, and they're on the right-hand side. So negative 20 plus 4 is going to give us negative 16x. x, bring down my 12, and a 32 minus 16x. All right, so let's go ahead and combine these like terms. I know I have a 16, a negative 16 on the left-hand side, and I also have a negative 16 on the right-hand side. So let's move it. Let's move from right to left. So let's go plus 16x, plus 16x. And we know that when we have a positive and a negative of the same numbers and variable, we have opposites, so those become 0. So I can cancel those out. And what am I left with? 32 equal to 12. Now we know that 32 does not equal 12. So in this case, when we end up with a problem like this where our whatever's left over do not equal to each other, we call this no solution.